In this lesson, we're going to learn how to use long as well as synthetic division to divide polynomials. Starting off with long division, same as you remember from elementary school, what you're dividing by goes on the outside, and what you're dividing into goes underneath. Again, similar to the long division you learned in elementary school, you take a look at the first piece. It used to be place value, now it'll be the first term on the outside, and ask how many times it goes into the first piece on the inside. Another way to ask this question is 4x times what gives us 4x cubed? That answer is x squared. Multiply that x squared by both pieces on the outside, and then subtract. It's helpful to distribute that negative sign. 4x cubed minus 4x cubed cancels. Negative 7x squared plus negative 5x squared is negative 12x squared. And then we bring down the next term, and we repeat that process. 4x times what gives us negative 12x squared? That would be a negative 3x. Multiply that negative 3x by both terms on the outside. Subtract, again distributing that negative sign is helpful, adding is easier than subtracting. The negative 12x squared plus 12x squared cancels. Negative 11x plus 15x gives us 4x. And bring down the next term. 4x times what equals 4x? That would be 1. Multiply that 1 by both pieces on the outside. Subtract, distribute the negative sign. In this case, we have no remainder. What that means is that 4x plus 5 is a factor of 4x cubed minus 7x squared minus 11x plus 5. And the result after division, or the quotient, is x squared minus 3x plus 1. Taking a look at that again, the x minus 1, what we're dividing by, goes on the outside. Notice this time we're missing some terms. We're missing an x squared term, and we're missing an x term. So we have to put those placeholders in under the division bar. X times x squared gives us x cubed. Multiplying that by both pieces on the outside. Distributing that subtraction. Now we can add our terms. Adding is easier than subtracting. Bring down the next term. X times x gives us x squared. Distributing that x to both terms on the outside. Distributing that subtraction so that we can add our like terms. Bringing down the negative 1. X goes into x once. So again, we have a perfect factor on this one. So x cubed minus 1 divided by x minus 1 is x squared plus x plus 1. One more example of long division. This one's a little bit more complicated. We're dividing by a trinomial. Same process, x squared times 2x squared gives us the 2x to the 4th. Multiplying that 2x squared by everything on the outside. Distribute your subtraction. Add your like terms. Bring down. In this case, because our x cubes canceled as well, we need to bring down 2 terms so that we have 3 terms to match the 3 terms on the outside of the division bar. X squared times 1 gives us that x squared. Multiplying that 1 by everything on the outside. Distributing our subtraction. And adding our like terms. This time we do have a remainder. So here's how we write our remainder. We add our remainder on the end. Think about if you had normal numbers, your remainder turns into a fraction with the remainder over what you divided by. So that's how we set it up for polynomials as well. Next, we're going to take a look at synthetic division. What synthetic division allows us to do is just use the coefficients to divide, and we don't have to mess with the variables at all. The only way that we can use synthetic division is if what we're dividing by is a binomial with the highest power of 1. We cannot use synthetic division if you have a power of 2 or more. So we start by setting up the coefficients in a box, the coefficients of what we're dividing into. So the 3x cubed, negative 17x squared, 15x, and negative 25. Then we take the value that we're dividing by out of the asylum. So right now it's in the asylum as a negative 5. We're going to pull it out as a positive 5. To do synthetic division, you simply drop that first term, multiply that 3 by the 5 on the outside, add your negative 17 and 15, multiply the result by 5, add your 15 and negative 10, multiply the result by 5, and add. That last piece, if that is a 0, that means you found a factor. There is no remainder. And here's how you express your answer. You put the variables back with the coefficients that you got as a result of your synthetic division. So starting off with that 3, we're going to drop 1 power from what we were dividing into. So instead of 3x cubed, we've got 3x squared minus 2x plus 5. So what this tells us is that 3x cubed minus 17x squared plus 15x minus 25 divided by x minus 5 gives us a result of 3x squared minus 2x plus 5. We'll look at that one more time. Synthetic division is a bit easier than long division, so it doesn't take as many examples to catch on to. We've got 5x cubed minus 6x squared plus 0x. Just like we needed that placeholder with the long division, we also need it with synthetic division if any terms are missing, plus 8. Pulling that 1 out of the asylum, drop the 5, multiply by negative 1, add, multiply by negative 1, add, multiply by negative 1, add. In this case, we have a remainder, so we'll see how to set that up. Putting those variables back by dropping a power, we start with 5x squared minus 11x plus 11. And then again, we do that remainder. In this case, our remainder is negative, so I can do minus 3 over that x plus 1 that we are dividing by. Notice I went back to the x plus 1 that was actually what we're dividing by and not that minus 1 when I pulled it out of the asylum. And you have 2 U-Try questions.